All right, watch and listen carefully here, guys. So our first question, okay, quite simply is just an unbanked curve. What holds you in an unbanked curve? Friction. Okay, so let's have a mark for givens here. We know the radius of the corner is 25.0 meters, and the maximum speed is 18 meters per second. Okay, so 1 mark there for their givens. Okay, that was all we were told. And then we have that for any unbanked corner, the centripetal force is provided by the force of friction. Okay, so either they wrote it that way or they wrote it this way. Okay, because obviously normal force on a flat surface is equal to the force of gravity. All right, so we are trying to find the coefficient of friction. So we're looking for mu. So m's going to cancel. We're going to divide both sides by g, and we're going to be left with v squared over rg. All right, so if they have that mu equals v squared over rg, or they have the numbers plugged in, 18 squared divided by 25 times 9.81. Either one of those is worth their third mark. Okay, and our final answer for mu it's going to be 1.32. Yep. Okay, and it's unusual for mu to be greater than 1, but in this case it is. Okay. It is, sorry, just two significant figures, 1.3. All right, any questions on that one? Okay. For question number 2, this is our first vertical circular motion problem on a quiz. Okay, so this is the situation we have. We are going over the top of a vertical circle. Okay, the apparent weight of the rider is 350 newtons. Okay, we're looking for the radius of the hill. Okay, we know that the speed is 45 meters per second and the mass is 180 kilograms. Okay, so 1 mark for givens. Okay, in terms of forces, what would this force be? Gravity. What would this force be? Normal force, apparent weight. Okay, if I push on the track pushes up on me. All right, those are my only two forces. There isn't anything else. So for any vertical circle, FC is forces in minus forces out, okay, which would then mean gravity minus apparent weight. So if they have something like that, okay, give them a mark for that. All right, so we then have, if we are looking for, so we're looking for the radius here. Okay, so we're going to have mv squared over r equals, I mean, we can calculate these two numbers, but we can leave them like this, okay, minus 350. Okay, if I want to look for r, I want to swap r over to this side and then divide this back over here. Okay, so it's going to end up looking like this. Okay, so give them a mark if they kind of got to that step there. Okay, so we're up to 3. All right, so plugging in all of our numbers here, we're going to have 180 times 45 squared divided by 180 times 9.81 minus 350. Give them a mark for that, and that'll give us our answer for the radius of the hill. All right, so the radius of the hill is, and we only have, what here for sig figs? 2. Okay, so we would have 2.6 times 10 to the 2 meters. Fifth and final mark. All right, so it's at a 9. Give them a mark out of 9, let them see it, and then I'd like them in a nice neat pile right here.